Hey everyone, welcome back to the channel. Today we're diving into one of my favorite topics, microservices communication patterns. Whenever you build large-scale systems, one of the biggest challenges isn't the code, it's how your services actually talk to each other. Should you use REST, maybe gRPC, or something asynchronous like Kafka? Each of these choices changes how your system behaves, performance, reliability, scalability, everything. So in this video, I'll walk you through 8 communication patterns that every system designer should know, when to use them, what problems they solve, and how they fit into modern architectures. Let's get started. Let's start simple, REST. This is the classic way services communicate using HTTP. It's stateless, simple, and works everywhere without needing any special client libraries. You usually send data as JSON or XML, which makes debugging straightforward with browser tools or Postman. Its synchronous nature means you get an immediate response, great for predictable request-response operations. REST is perfect for front-end backend communication or small internal APIs. The only drawback is that if a downstream service is slow, you wait. Next up, gRPC, which is basically REST on steroids. It's built on HTTP, too, and uses protocol buffers instead of JSON, giving you smaller payloads, type safety, and around 10x faster performance compared to REST for internal service calls. It also supports bidirectional streaming, so data can continuously flow between services. And thanks to HTTP, 2 multiplexing, you can handle multiple requests over a single connection efficiently. You'll see gRPC heavily used in systems built by Google, Netflix, and other high-performance architectures. Now, for real-time features, WebSockets are essential. Think of chat apps, notifications, stock tickers, or live dashboards. They keep a persistent, bidirectional connection open, meaning the server can push updates instantly without the client pulling. This eliminates HTTP handshake overhead and ensures low latency, making it perfect for collaborative tools or live interactions. Just remember, managing thousands of open connections requires careful scaling and resource planning. Now let's step into asynchronous communication with Kafka or RabbitMQ. Instead of one service directly calling another, it just publishes a message to a queue or topic, and moves on. Consumers can then process those messages whenever they're ready. This decouples your services, meaning producers and consumers don't need to know about each other or be available at the same time. With durable queues, you prevent message loss even if services crash. And with pub/sub models, you can easily add new consumers without touching the producer. Kafka especially can handle millions of events per second with horizontal scaling, making it a backbone for event-driven architectures. Next up, event sourcing. Instead of just storing your current data, you store every state change as an immutable event. That means you can replay all events to rebuild the system state at any point in time. It's amazing for audit trails, debugging production issues, or even time travel debugging to see how your system evolved. This approach is popular in financial or enterprise-grade systems where data integrity and traceability are critical. Let's talk about sagas, a key pattern for maintaining data consistency across multiple services. In microservices, one user action might span several services, like placing an order, charging payment, and updating inventory. If one step fails, you need to roll back the previous ones. That's where compensating transactions come in. Each step in a saga has a corresponding rollback step. You can implement sagas using orchestration, a central controller, or choreography, services reacting to each other's events. It's a must-have pattern for payment flows, booking systems, or order processing pipelines. Now here's one that protects your system, the circuit breaker pattern. If a downstream service starts failing repeatedly, you don't want your system to keep hitting it and crashing everything. The circuit breaker will open the circuit after a threshold of failures, giving that service time to recover. Meanwhile, you can serve fallback logic, cached data, degraded responses, or error pages. Once the service becomes healthy again, it auto-closes and resumes normal requests. It's essential for resilient and fault-tolerant architectures. And finally, the API gateway. Think of it as the single entry point for all client requests to your microservices. It handles authentication, rate limiting, request routing, and can aggregate multiple backend calls into a single client response. This reduces client complexity, improves security, and minimizes round trips. Almost every modern microservices system today, from e-commerce to streaming platforms, uses an API gateway as its front door. So these are the 8 microservices communication patterns every system designer should know: REST, gRPC, WebSockets, Kafka or RabbitMQ, event sourcing, Saga, circuit breaker, and API gateway. Each one tackles a different concern: speed, scalability, consistency, reliability, or resilience. And in the real world, you'll often combine them together, for example, using REST for client APIs, gRPC for internal communication, Kafka for async messaging, and circuit breakers plus API gateway for resilience. If you found this video helpful, hit that like button, subscribe to the channel, and comment below. Which of these patterns do you use in your projects? I'll be posting more deep dives into system design and backend architecture, so stay tuned. Thanks for watching, and I'll see you in the next one. Bye bye, take care.